We're going to take a look at solving quadratic functions, and also some of the other topics include complex numbers and polynomials. So let's review our 4 strategies for how to factor. The first is pulling out a greatest common factor. So in number 1, you're going to pull out a 2x, and you're going to write what you have left after you divide each of those terms by 2x. So I would have x plus 10 left, and that's as far as I can go. On part B, you have a difference of squares situation, and so you were going to take the square root of each term. So I would have 2x and 5, 2x and 5. I'm going to put one with a plus sign and one with a minus sign. So for the pattern of difference of squares, whatever this is, you take the square root, give one a plus and one a minus. C is the diamond method, so we're looking for the factors of 32 that add up to negative 12. So in this case, it would be negative 8 times negative 4. And then you can just write those as the factors. So x minus 8, x minus 4 is my final answer. The difference between C and D is now I have a value in front of the x squared that's bigger than 1. So I'm going to do the box method. And 3x squared goes in the top of the box, and negative 5 goes in the bottom of the box. And I still need to do the diamond method to find these other two positions. I do 3 times negative 5. So that's a difference from over here. We only had to use the number 32 because 1 was sitting over in front of the x squared. 3 times negative 5 is negative 15, and I'm going to put negative 14 down in the bottom. So the factors are negative 15 and positive 1. So I have negative 15x and positive 1x. To finish my box, I'm looking for basically the greatest common factor. What am I going to multiply out here to get inside the box? So in this case, it would be 3x times x times 1 is 1x, 3x times negative 5 is negative 15x, negative 5 times 1 is negative 5. So my final answer is 3x plus 1 times x minus 5. So the only difference between part 1 and part 2 is now you have this equals 0. So that means you're going to now solve the whole problem. So we have to recognize which of the 4 examples we have here. This is a difference of squares example. So I can write my factors as 2x plus 3 and 2x minus 3. And then I have to set each of these separately equal to 0 and solve for x. So if I set them both equal to 0, first I would subtract 3 to the other side and divide by 2. So x would be negative 3 halves, or on this problem, positive 3 halves. So these are my two x-intercepts on my graph. In example B, first you'd look for a GCF, but there isn't one, so we're going to have to do the box method. And we've got 2x squared, 4. We're going to set up our diamond. 2 times 4 is 8. 9 is going to go on the bottom, so I want to use 8 times 1. 8x and 1x are going to go in my box. So now I've got 2x times x times 1, 2x times 4, 1 times 4. So my final factored answer, 2x plus 1, x plus 4, I'm setting each of these equal to 0. So 2x plus 1 equals 0, and x plus 4 equals 0. So x in this case is negative 1 half. X in this case is negative 4. What about completing the square? So to complete the square, we need to get all of our C value term on the right-hand side. So I would start by adding 3 to both sides of the equation. So I have x squared minus 8x equals 12. I need to figure out what to add in this position. So I cut this number in half, negative 4, and square it. So I'd have adding 16 on both sides of the equation. Now this is a perfect square trinomial. So I can factor into x minus 4 squared, because it would be x minus 4 times x minus 4 would give me this trinomial. So I have that is equal to 28. So my next step would be to take the square root of both sides of the equation. So that gives me now just x minus 4 over here equals plus or minus When I reduce 28, that's 4 times 7, so 2 root 7. So my final solution is x equals plus or minus 2 root 7 plus 4. Example 4, solving by taking square roots. This is similar to completing the square, but now see how I don't have that x term to worry about? I only have x squared. So my goal is to get x squared by itself. So first I would add 9 to both sides of the equation to get 20. Then I would divide by 2 on both sides of the equation to get 10. Now I can take the square root of both sides of the equation. So x is equal to plus or minus the square root of 10 because I can't break 10 down any further. On example B, you're going to treat this like your x squared. So don't go and FOIL that out. Just subtract 4 to the other side. So you have x minus 8 squared equals 8. Take the square root of both sides, so x minus 8 equals plus or minus 2 root 2. So my final answer, plus or minus 2 root 2 plus 8, is how I would get x by itself. Number 5 is to review the quadratic formula. You would be given the quadratic formula on your test. You identify A, B, and C in the equation, and you make sure that it's equal to 0. So A is 3, B is -6, and C is 1 in this case, and I plug all that into my equation. So the opposite of B would be +6, plus or minus the square root. B squared would be 36, minus 4 times A times C, and the whole thing is being divided by 2A. So 2 times 3. So our first step would be look under the radical, or actually, I'm going to reduce this or simplify that to 6 first, and I'll just show you how to type it into your calculator. So I'm going to do 6 plus first. 6 plus the square root of 36 minus 4 times 3 times 1. I'm going to hit enter and then divide that number by 6. So my first solution is 1.8, or, now look, because this is typed in correctly into my calculator, I can arrow up, hit enter, reselect that amount, and just change that sign right there to a minus sign. Hit enter and divide by 6. So 0.18. So my two solutions, 1.8 or 0.18. The discriminant. So the discriminant just grabs this one little piece that's under the radical and it asks you, is the discriminant negative, meaning there's no solution, positive, meaning there's two solutions, or is the discriminant 0, so there'd only be one solution? So let's just grab this. Oh, it's similar, but it's not the same. So I'm going to do b squared. So b squared is 16 minus 4 times A times C, and see what I get when I type that into my calculator. 16 minus 4 times 3 times 9 gives me -92. So if I have -92 as my discriminant, I have no solution as my answer. Complex number operations. If you are just adding two complex numbers, you're just going to add together the like terms. So I would have 9. And then 1 minus 6i would be minus 5i. If you're multiplying, you need to use FOIL. 2 times 7 is 14. 2 times -5i is -10i. 7 times I is 7i. I times -5i is -5i squared. Whenever you see I squared, that is equal to -1. -5 times -1 is the real number, +5. So when you're combining like terms, that gets added to 14. So you really have 19 minus 3i as your standard form answer. In part C, you're going to have to write this out, 2 plus I times 2 plus I. 2 times 2 is 4. 2i plus 2i will be 4i. And then I times I is I squared, which we already said was -1. So I really have 3 as my real number and 4i as my imaginary part. And in part D, just don't forget to distribute the negative sign to both terms. So this is really 5 plus I minus 2 plus I when I distribute the negative sign, which would be 3 plus 2i as my final answer. In number 8, solving for real and complex solutions, that's just using square roots. But this time when we get to the roadblock of the negative number, so subtract 8, divide by 2, you're going to take the square root and continue on to get an answer. So in this case, x is equal to plus or minus 2i. So I'm really breaking this up into the square root of 4 and the square root of negative 1. And the square root of negative 1 is I. So I can write this way. X squared plus 16 equals 0. My first step would be to subtract 16 to the other side. So when I take the square root of both sides, I get that x equals plus or minus 4i. Y is each not a polynomial. So we've got a negative exponent, an x that's trapped under the square root, and a fractional exponent. The other thing that it cannot be is a negative, or sorry, an imaginary coefficient. So if you had like 2i x squared or the square root of negative 4 with the x outside, these also would discount this from being a polynomial function. In a quick review of polynomials, I will do this first side and then you can pause the video and try this side and make sure that you understand it. Writing in standard form, so I would rearrange negative 2x squared plus x. This is a degree of 2, so that would be quadratic, I should write. Classified by number of terms, it has 2 terms, so binomial. End behavior. I've got a negative coefficient, so right end goes down. I have an even degree, so the left end is also going to go down. The maximum number of turning points, if you think about a quadratic, how many turning points will it have? 1. How many x-intercepts could it have? It could have 2. So that would be the maximum number of x-intercepts, but we know that some quadratics have no x-intercepts. So now pause the video and try the other side and then come back and check your answer to make sure that you understand it. So we've got y equals 3x cubed minus 2x squared plus 45. The degree of this one is cubic, and this is a trinomial because there's 3 terms. The end behavior this time, the right end goes up from that leading coefficient and the left end goes down because the degree is odd. A cubic function could have 2 turning points, one less than its degree, but some cubic functions have no turning points. So that's why we say maximum number of turning points. And it could again have 3 zeros. So if the function looks like this, it could intersect the x-axis 3 times, but some cubic functions only intersect the x-axis once. So the maximum will match the degree, and the turning points will be 1 less than the degree. Finding zeros. I'm going to start with part B because it's already in factored form, so I can explain multiplicity. My 0 here is -5 and +1, so it's what you have to plug in to make it 0. This has an even multiplicity because the degree is 2. This has an odd multiplicity because its degree is 1. So now let's find our zeros by factoring the second equation. So x is my greatest common factor, and then I would have 1 minus x squared. Recording. So you would take this is difference of squares, so x times 1 minus x and then 1 plus x. So I have 3 x-intercepts at 0, at 1, and at -1, and they all have odd multiplicity because they all are to the first power. So in number 12, this is a review of just some polynomial operations. They're very similar to when we looked at imaginary numbers. I'm putting this in standard form, so I always search for my highest power first. So negative 4x cubed would go first. And then 3x squared and 7x squared, so plus 10x squared. And then 2 minus 10 would be minus 8. So it just says write in standard form. And then in part B, just be careful to distribute your negative sign over that second parenthesis. So you'd have 4x squared minus x minus 3. And now I can combine my like terms. So it looks like 4x to the fourth would come first, then x cubed, then 4x squared, and then I have a negative 7x and a negative x, so negative 8x, and then minus 3. In part C, this is multiplication, and to stay organized, I like to use the box method for multiplication. So I'm going to put 4x squared plus 3 down the side, and x cubed, 4x squared, and negative 7x across the top. So I've got 4x squared times x cubed is 4x to the fifth. Remember, you add your exponents, and then I've got 3x cubed. And then 4x squared times 4x squared, 16x to the fourth, and then 12x squared. And then I'd have negative 28x cubed and negative 21x. So my final step is look for any like terms. It looks like I only have one set of like terms. So 4x to the fifth plus 16x to the fourth minus 25x cubed plus 12x squared minus 21x is your final answer. And the last one before you have to do your guided practice is to do some division. And so for this division, you put your divisor on the outside of the box. So x minus 2 goes outside the box. We're trying to produce the dividend inside the box. So we're going to put x cubed first. Now we're going to look for our quotient. So our quotient is going to come up here. So I would have x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Now on this diagonal, I need to produce 4x squared. So what needs to go here so that these add together to get you 4x squared? It would be 6x squared. Now you fill in the top of the box, so 6x. 6x times x is 6x squared. 6x times negative 2 is negative 12x. Now I need to fill in the box to get 0x in my dividend. So I would need positive 12x to get a total of 0 there. So the last term in my quotient is going to be plus 12. So this is my quotient. The rest will be my remainder. So 12 times x is 12x. 12 times negative 2 is negative 24. To get to negative 7, I would need to add 24 minus 7 is 17. So I would have to have 17, which is my remainder. I don't really care about the remainder, really just care about the quotient, but nice to know the remainder was 17. Thanks. Good luck on the guided practice.